But so check out the hiring page. If you just want to have a chat, just want to sort of inquire about what's available, the lady to talk to is Sarah. I put her email address at the bottom. That's me done. Thank you.
I think I'm up next. Let me. Yeah.
I'll hold this while you do the plugging of leads. And you're welcome to talk to me as well if you want to talk about Waveworks.
You can ask him questions now.
Yeah, I don't take bug reports after 6 p.m. though, so.
That's the kind of company they are. After 6, he catches beer bottles and everything.
We'll get that on the slow motion on video later. Does anyone know any jokes? I think it's coming up now. Yeah, I'll take this away.
Hold this mic. And happy Kubemass. Is it going to come up? Come on, come on, come on. Apparently this is one of slow monitor. Our projector likes to take its time. Oh, yes. Excellent. So, nice to see you all. I was told for this talk by Milosh, look nostalgically at our accomplishments, shed a tear for Docker, and rally up for 2020. Well, it's kind of weird because I work for Docker, so it's like, I was like, yeah. Actually, I think he thought I was going to talk about whatever I talked about at KubeCon, but I'm not going to talk about that because I already talked about that last week, and I don't like doing the same talk twice. And he also said, Justin Cormack is a grandmaster of security at Docker. And also, it turns out that all the people talking tonight work in security, which is kind of interesting because they're all my friends and they're all really cool people. And and I'm a thought leader as well, which is a bit weird. I'm not sure I like that term. And I like lots of interesting, weird stuff, which is true. So I thought I'd give you a really random talk, really. I thought I'd talk to you about, for reasons that might become clear later in the talk, or maybe not, we'll see. Well, actually, I thought I might mansplain myself or something. I don't know. I thought I might just talk about, like, why I got here and why I'm talking about security and why I got interested in security and why I'm doing other things. And also, what is up with Docker? Because I thought you were all going to ask that anyway, so I might as well tell you. I come from this place now. I used to be a Londoner, but I now live in this place, which is Cambridge. This is up the road. Cambridge is a tech village, just an hour, 50 minutes away on the train, full of things like radio telescopes. This is where radio telescopes was where the quasars were discovered 50 years ago. It's kind of cool. But it really is a tech village. Like literally, actually, Milos really likes it. It's a sort of place you go along and people come along and. As Clive James actually said when he was dead yesterday, you never know if the person you're talking to is an atomic physicist or not. I'm going to tell you a bit about working in security and why I'm doing it and kind of how I got there. I stole all these cartoons from the Docker cartoons that we've had for many years, and which rumor has it may be coming back more. Now I'll tell you about that later. Anyway, how did I get into security in the first place? Many years ago, I was a sort of old school sysadmin, and I used to work with computers, and I discovered that computers got hacked all the time, and everyone seemed to miraculously always know the root password, even when you just changed it, and things were kind of weird. And it was interesting. That was kind of before DevOps, and actually, then I became a developer, and then when DevOps came, it's like, yeah, DevOps is really cool because I'm both those things. And so I used to, I've spent my time in Belgium doing DevOps things, being interested in that and just trying to understand how these relate to each other. But I was curious about these sort of attacks that were happening and about security issues. And I worked on product, and I used to have this thing where I spent like 15 minutes on a Monday at 10:30 where I'd try and find a security issue in our product. and pretty much every week I would find one. So I guess I was kind of always interested in that, and like everyone should do that. Every week you should spend 15 minutes or half an hour and see if you can find a security issue in the product you're working on. It's the first time it's probably hard, and the second time it gets easier, and you just have to think about it more. But it's a really good, interesting discipline. And it's kind of, I think it's a mix of understanding that there were people hacking into stuff just by being a sysadmin and discovering that was true, and finding that I could work out how you could do it as well. That got me into that. I also spent a lot of time, I think, more than, well, yeah, actually, I know I spent a lot of time getting into deep internals of things, which is incredibly kind of useful, because deep internals are kind of where the bad thing, the weird things come out of. I I think, I mean, yeah, Jesse Frizzell once persuaded me that I should write some blogs about all the system calls I liked and hated, and then so I did that once, and um, it was like, yes, because I knew, for some obscure reasons, I knew all the system calls, like Linux system calls, like they were my friends. I also, I worked in finance for a long time. I didn't always work as an engineer. I worked in finance. So I spent time working on risk management, and security is actually fundamentally risk management. You've got to make a judgment. How likely is this thing to be hacked? How likely is it not to be hacked? I think my kind of time in finance was very useful from that point of view. I understood what risk was about, and about the formal and lack of formal things that you have in finance. Like people love the Black Scholes model of option pricing, and yet actually in practice, the people who invested most with that model lost all their money. And I never had any formal security training. If you're thinking of going to security, don't worry about that. Just interest is far more important. And I think one of the things that's interesting about security is it's very different from other tech jobs in a way. You're not. It's very much less routine. You're doing different things. There's a huge range of different roles in security. There's attack roles, defense roles, red team, blue team, whatever you want to call them. You're exploring all the possibilities that are not expected. I think that there's this thing about the happy path that we talk about, which in security, which is like, or actually any kind of quality bug testing, like the happy path is where the user does what you expect. Does it work? That's what you usually test in your test. Like, user wants to buy something from the shopping cart, buys something. Does it work? Great, happy path. But the unhappy paths are all the other things where the user decides to try and change the price by editing the price on the web page and submitting the form, and buying the thing for half price or free or whatever, or the user totally bypasses your authentication, or the user decides to try and change the URL and see what happens if they change the customer ID and see whether they can also buy something but let someone else, and things like that. So these things are kind of fun. I sometimes say that security is the same as quality, but as I say, it's like quality but with clout. You can, like, if you're in security, if you're in quality, people, if you're working QA, it's a job that it's a great job, but people often ignore you. If you're in security and you tell people you have to do something, you can be really mysterious and not tell them the reason why they have to do it, and they will do it, and it's great. And you can abuse this. It's true, but you can also. It comes back to risk management. Sometimes you have to tell people to do things that they don't know why you have to do, and they say, "Why should I do that? That's not very important." And you say, "It's P0," and then they have to do it. And it's like there are times I've done that where I've not told people why they have to do something. I like to tell people why. I mean, it's sort of it's important to sometimes to Actually, I'll come back to this later. A bit about the bit about where you can't tell people why you're doing things. But uh, people in security, I've met lots of really nice people in security. Everyone else who's talking today, they're really nice people, and there's a whole security community. I think it's I think it's it's a nice community to work with. They're different people from you to meet otherwise. You also get to meet lots of exciting people in exciting roles like compliance. I once went to a meeting with one of our customers who was an insurance company, and I had to do a talk. I forget what the talk was about, in a room with 30 people, and I asked them what they did, and they were all in compliance. And I'd never met 30 people in compliance at the same time before. I used to work with one person in compliance when I worked in finance, and it was like, oh, we've got 30 people in compliance. That's exciting. And they were like, you all want to come to my talk. It must be really interesting. And also, the other thing about working in security is like, it's really hard to hire people. So we need more people in security, is definitely the case. I want to tell you a little bit about things I work on in security. It's a kind of random list. I mean, at Docker, I think my job title is security lead, but I basically work on everything. But I think the first thing I worked on was SecComp, which I as I said, I worked with Jesse. It was good fun. I kind of intimately knew all the system calls, and we put this thing together. And Kubernetes is going to adopt it soon, by default. It's only been 4 years. But anyway, it's kind of you could ask me that about other things. I work on Notary, which is a CNCF project about container signing, which we're doing an exciting reboot of, which I can also talk about. Supply chain security is something that I'm really interested in. So supply chain security is this really kind of fun area where basically people have discovered that actually the easiest way to hack you is to hack your Jenkins instance and like stick some other code in it that wasn't what you wrote. Because, to be honest, like your production environment's kind of secure now, but you forgot to secure your Jenkins instance. There's more bits of that as well. I mean, there's loads of ways you can hack the supply chain, but it's basically anything that you put in that's at the beginning, like hacking someone's GitHub account or anything else. But Jenkins, it's the easy way. I work for CNCF SIG Security, which is a group of people who's come together actually this year, and it's a really, really nice group of people. I put their we have a logo as of a few weeks ago, and it's the Trash Panda. It's the security Trash Panda. We love our logo. We're a group of people who help people across all the CNCF projects work on security things. It's open to everyone. If you want to contribute, Google it, join. You can come along. We have we have a really, really, really broad bunch of people working on a broad bunch of things and a lot of expertise, and we just try and help people who are getting into cloud native security work out what they need to do and try and find things we can help people with. And it's been I found it really, really productive. The people are really lovely, and I think we're starting to work on a bunch of projects. Which are really designed to help end users of projects work out what kind of security things they need to do. So we've been working, we're working with a broad bunch of end users and projects to try and work out what kind of security things people have problems with and how they need help and what we can do to help. And it's really just a helpful bunch of people being nice to people, which is what I like. And I've also worked on security instance. I don't know if you heard about the Docker Hub security instance a few months ago, or whenever it was. I forget when it was. Yes, that occupied about a lot of my time. We scheduled it to be during DockerCon, so I could enjoy our conference by being in a room in a hotel next door, not canceling all my talks at the conference and sitting in a room. Um, I'll talk about a little bit, but anyway, I'm also interested in stuff that's nothing to do with work. I think one of the things I've learned about security is that it helps to learn about things. You kind of have to divert from the stuff that you actually do on your day-to-day job. And I've spent a bunch of time trying to help out with it. So the noise protocol framework is a kind of, it's a sort of equivalent and related thing to TLS 1.3. You could sort of say it's um, it actually influenced TLS 1.3 design quite a lot, but it's much simpler and easier to understand. And I spent a bunch of time working on improving docs and like kind of helping out in that, which was, I learned a lot about how cryptography works and what goes wrong from that, and it was really helpful. I'm kind of, as Milosh knows, obsessed by capability-based security, which no one uses, but solves a lot of problems. I've done some talks about that and things like that. I'm interested in programming language and security and what we can do to make things more secure. I've actually spent quite a lot of time running tracks at things like KubeCon. I don't actually I've never run the security track at KubeCon, but because of my interest, like my talks are often about security. So I'm particularly, so Felipe's talk, you should definitely watch that. It was a brilliant talk about, I persuaded him, he didn't really, I'm not sure, well, he was really happy to do it, but he was surprised to be asked, I think, to talk about, what it's like to maintain the crypto libraries in Go and what the values are and why he does things. And there's another talk in that track about security in JavaScript that I was really, really happy about. So anyway, getting people to, getting security in front of a wider audience, I think, is something that I spend quite a lot of time doing. And I've recently got interested in security research. I met Thomas a while ago, and he wrote an amazing paper, which there's a bunch of follow-up papers about how do you define an insecure bit of software? What does it actually mean? So I'm a bit of a geeky academic nerd sometimes. So that these kind of things, these are things I sort of do on the side, and I think they've really helped me understand more in my job about what's significant, what's not significant, I think um, um, other than just like the kind of day-to-day stuff, just kind of getting a better idea. Security is an area I think there's a lot of problems. A lot of people I know who work in security have had burnout problems. I think it's definitely an issue. The biggest thing is, which as sort of referred to before, is you can't often tell people about what you're doing in your job or anything about it at all. Like a huge amount of stuff that during security stuff that you really can't talk about, and that really makes it hard to. I think it makes things like burnout actually worse because it's harder to talk about things to people. Because normally as an engineer, you can just talk about anything you do. It's not a problem. Like, I mean, I've worked in open source much of my career, and you can you always want to talk about everything. You talk about everything all the time. It's like it's fine. In security, there are things I couldn't tell anyone about, and um, we actually have there's a great meeting that Segment does in SF about things where you really, really broke something, which is actually called Segmentation Fault, which is a good meetup if you're in SF. Okay, occasionally, and it's people confessing they did really bad things, and I think those things are really good. But I couldn't talk about most of those things. I could talk about bad things I've done not in security. Those are good. I can tell you lots of stories, but yeah, since I've been working in security, I mainly can't tell you about a lot of things, which is disappointing. Like in those bits of my work, I mean, the stuff where I'm writing, like notary and stuff, that's fine. But there's not enough people in security, and I think people often feel they're overworked. I think that's definitely a problem. So, like, people should go and work in security so we don't have that problem. And there's this sort of, we talk about this happy path and things, but in a way, security people are not on the happy path of like things being normal. There are people get paranoid and unhappy, and and I know a lot of people left security, and it's kind of, I think there are, it's important not to understate these issues, and so I think, but it's a fun area, and I think that everyone should spend some time working on security. I think it's pretty important. Oh yeah, sorry, I was just saying, so I'm going to talk about Docker because for various reasons this talk. Well, for a start, I couldn't not talk about Docker, and because people are kind of interested in what's going on. I spent a lot of last week at KubeCon talking about what's going on at Docker, and also, actually, I'm probably going to spend a bunch more time on non-security things, and that was kind of, in a way, the sort of sense of this talk, that like I was going to spend more time on non-security things, so I should talk about why I did security so much of my time. But I'm going to still do lots of security, but I'm also going to do more other things because we've kind of, things are changing. So I found this sort of interesting metaphor. This was this. I searched for whale explosion because obviously that's what you search for when you kind of you know, when people ask what's happened to Docker, it's like, it seems to be going on. So this is a brilliant story. If you look at the Wikipedia article about whale explosions, someone accidentally, or possibly on purpose, used 20 cases of dynamite, and when 20 sticks would have sufficed to. Because apparently the thing you're supposed to do if you have a whale, it's going to explode of its own accord, but you could stick some dynamite in it, and the idea is that it would, just break up into small pieces. But this whole thing, Wikipedia was about this amazing thing where this guy decided to use 20 cases of dynamite, and he flattened his new car he just got in there, get a whale of a deal promotion, which somehow reminds me of people used to tell us that Docker just sold T-shirts. And anyway, it was destroyed by a chunk of falling blubber. I just like, but that's not actually what happened to Docker. And actually, the future is actually kind of really interesting. And I'll tell you about this in a second. But I do want to kind of, as I said, I worked in finance once, and I have no reason to believe these numbers are wrong. I also don't have. I mean, these are numbers may be wrong. So this is the enterprise container business numbers that came out about 6 months ago, I think. Red Hat had 44% of the market. They were sold for $35 billion to IBM. Docker had 23%, and we sold our enterprise business to Mirantis for a small number, and no one else had much business at all in this market. But anyway, we had our enterprise business fundamentally. We've moved on to Mirantis with 330 of our 400 staff, and we're new Docker with 80 people, and we do developer tooling now. We're a little baby company. We've just done our Series A. It's a very exciting Series A. We've raised $35 million, and we are working on developer tooling, which is, I think, we're kind of going back to our roots as like doing stuff for developers and not doing the enterprise business, which, although it appeared to have lots of revenue, turns out to be unprofitable even at that kind of rate of revenue. It's a sort of, I think the economics of enterprise software are extremely interesting, and I know a lot more about it than I did a few weeks ago. But anyway, we're a developer-focused business now. We're a little baby, but we're actually going to have fun because we actually have the fun bit of the business. We're Docker Desktop, Docker Hub, the bits you actually use, not the enterprise stuff that you never bought. Which we didn't. None of us used either. It's like enterprise software. It's just that's not what. It's not what we use now. We were in the world of open source and cloud and all that stuff. Not hybrid cloud's made up word. Anyway, so anyway, so we're going to have fun. We're still Docker, and you know, we're still working for Docker, and so it's going to, you know, so actually this whole kind of thing is exactly. But anyway, so my role it will change a bit because I'm going to be doing other things as well as security. So I'm kind of, you know, that's why I kind of felt I should do a retrospective about what's like in security. And so, yeah, thanks very much. Thanks to Laurel who drew all the cartoons that I used. I hear the rumors that we may be going to use her more again now because we still love her. And I think people felt that she wasn't enterprisey enough, but we're not enterprisey anymore, so we don't care. Happy holidays and pay these people money now. Milos, is that what you wanted?
Can you leave this one?
Oh, yeah, sorry. Yes.
So I have an update. We have pizzas there. Pizzas are coming. Now, Marcelo is going to bring the pizzas, put them in that table and in that table. Try not to rush too much. We are a lot of people, so, you know. Enjoy. let's restart. If you can go back to your seats. Thank you. Just a quick reminder that you can still donate. It's very easy. You just get your telephone out and pay some money. Come on, give me your money. It never works. I don't know why. Are you ready? Do you have your microphone? So, the one and the only.
Does it work?
Should work.
Can you hear me? Cool. Let me put the cable. I think maybe, yeah, maybe in 20 years we'll have some technology that it's plug and play and works. Okay. Are we ready? Okay, welcome. I'm going to talk a little bit about a few ways that you can improve your security in the Kubernetes clusters. And basically, it's going to be about admission controllers and some other things that you can make with controls in the cluster. Okay. My name is Diego Comas. I lead the security engineering teams at Thought Machine. Thought Machine, it's a software company that we do core banking systems in the cloud. The technology for the neo banks. Okay. So, how many of you are using administrator controllers? Cool. Okay. How many of you are using Kubernetes? So, Kubernetes uses administrator controllers by default, but it's going to that. Okay. So, I think I'm really excited about this topic. It helps us a lot in governance and controlling multiple areas in our clusters. So I'm going to start introducing what administrator controllers do. So the admission controllers, it's one of the native features that you can enable in Kubernetes for security, and it's intercepting the request, the Kubernetes objects, and then there can be some logic, and then there's an output that I will show the diagram. But basically, when a request has been authenticated and authorized, then it handles the request and then does some controls, and then it can make it in the persistent. Okay, so as I was saying before, these are the default admission controls types that comes into the Kubernetes, but I'm going to focus on the dynamic ones, that are the bottom ones, mutating admission webhook and validating admission webhook. If I'm going a little too fast, don't worry, I will put the slides later online, but we have little time. Okay, so this is the process I was saying before. This is available from the Kubernetes documentation. The API comes in, and then there's an authentication authorization. Once past that, it goes to the mutating admission webhook. This one, it's with some logics from the webhooks that needs to run sequentially. It's going to be able to inject changes and a patch in your Kubernetes objects. So that is going to modify. Then after the modification, it goes to the object schema validation, because if you set up your webhook in the wrong way because you use Emacs instead of Beam, then it will validate that you're doing right and the spaces in the YAML and everything. And finally, after passing the object schema validation, it will go to the validation admission webhooks. We'll call multiple webhooks that can run in parallel. The main difference, and it's very important, the parallel and sequential, the mutating one change the objects, and if you got the wrong order, you're going to have bad time. So if you're going to say, I want all my objects. Okay. Do you hear me now better? Or the same? Okay. Okay. So this is very important because if you are using a mutating webhook and then you make the rule to modify things, but then one works before the expectation of the other, it's going to break a lot of things. And it's tricky because historically there hasn't been a certainty in the order of the webhooks. So you need to be careful because they can be ordered by alphabetical order, but in 1.15, I think you can put the priority control. Okay, so this is an example of using a mutating emission webhook, how you can inject things. You can define in your webhook logic, like, I want to include these containers in all the pods of my cluster. And then from the left side, you will see on the right side, it will add some containers. And this is very helpful in multiple situations, like you want to put some predefined login controls or things like Istio proxying that the rest of developers don't need to care, but you want to put the controls in automatically. And then we have the validating a mention webhook. This one, it's a binary decision, but it's just taking the information of the object, and then it's saying this is allowed or not according to the logic that I'm requesting. And this is for example, in our case, it has been very useful for supply chain security. Things I don't know if you heard about GraphS and Kritis. Kritis is an admission controller that will check some information in your object, and then it will try to confirm some attestations are matching with the information of that object. Okay. So what are the security features and opportunities that we have with admission controllers? So this is a few of the things that you can control, and this is quite good for security in our case, for governance, and saying like, we don't want in our clusters by default that the pods, then containers can run as privilege mode. So then you can put some admission controllers that will help you to avoid that. And then the same thing for other controls like host network, volumes, and run as root user. A lot of people like that, and like the, I'm not going to say, okay. But then, yeah, this is quite good because if some people just say like YOLO Helm install from the interwebs, and then they put a lot of root containers, that's not nice, okay? But you have a good control of your clusters, defining the policies. And it's also helping with the configuration to control, and they're not misuse of the objects. Okay, so I suppose the majority of you know that Kubernetes is very easy to use by default, but the security controls are not enabled by default, so there can be some problems. And this is an example of how we can define a policy, and the admission controller for the pod security policy will read this and it'll say, okay, I want in the full cluster that nothing can be privileged, and you will think that, yeah, all the developers that are using my cluster and are deploying software are going to comply with that, but you'll have some surprises. So I would recommend not to apply it directly. So we have had some time, like Henry will say, that it's applying the context security. It's not super easy when you're running a lot of microservices. So if you're starting from scratch, it's easy. Otherwise, be careful. Okay, so then we say like, we are going to do the best security at that machine. Our clusters, Kubernetes, were the most advanced, and in security for Kubernetes. Let's check the best practices and references. Kubernetes, the Cloud Native Foundation, Computer Foundation, from Andrew Martin. He's not here suspiciously for my mention. And then Google Cloud, Rancher, everyone. And I say, okay, do you think pod securities are helpful? Yeah, okay. I thought too. I love pod security policies. I can control security context. I can control Linux profiles, seccomps, everything. It helps me to sleep well. But then a few days ago, from the Kubernetes Security Committee, they say, oh, there's some problems with pod security policy, and PSP might never make it to GA. And I say, okay. So all my work is now, as Justin said, risk management. What is going to be the risk that we're not going with this, and we will be on the brink next week? So we need to take measures. And let's say, okay, but we said pod security is not going to work, but here you have some alternatives, so prepare yourself. And say, okay, let's see. So then we started to look alternatives, and I love Open Policy Agent, and Gatekeeper is one of the options. And Open Policy Agent is the new hype train. So what is going to provide this Open Policy Agent? So an easier way for creating the admission webhooks. One piece that I didn't include in the previous slides is it's a little bit complex to register your admission webhooks, because you need to initialize them, generate the certificates, interact with the API, and it's a little bit tricky. But if you can leverage something that it's already supported and generic, that helps you a lot creating the controls. So this is a little bit the diagram how Open Policy Agent works. Open Policy Agent, how many of you know what Open Policy Agent is already? Okay. How many of you are using it already? Good. Let's do the fan club. Okay, so it's really powerful in my opinion. It has a simple concept of it's policy agent that it's going to receive some JSON. It's going to compare the content of the file against a policy defined in Rigo, and then it will give back yes or no. And the Rigo, it's a domain-specific language that it has been created purposely for generating policies. We have seen in our code that generating the policies with Rigo, it's much quicker to share the code and understand what is going to do that, rather than, for example, policies in Python. So it's like at least 50% shorten the amount of code that we need to support, and that helps a lot. And yep, Open Policy Agent will help you govern how a system should behave, like things that you can do with admission controls, pod security policies. Okay, this is an example. This is from the Open Policy Agent website, where you're defining a rule saying like, if you are checking the, let's check, yeah. If you're checking the request and the object and say, check the image, it needs to start with the predefined registry that we want, and otherwise just print the error message when checking the pods. This is quite useful because as we know, there are a lot of dodgy images. Oh, we know that, right? Yeah, okay. So there can be some dodgy images in the interwebs, and then if you have more control of your registry, then the risk is lowered by that. So this is an example, and it's just like 8 lines of code on Rigo, and this will be a little bit more verbose in our languages and a little bit more difficult to understand. Rigo, it's something fairly new, this domain-specific language, but then you have like the Golang playground. You have like a playground for Rigo, where you will be able to test the syntax, the language, and see what is going to be the outcome of that validation. And then I'm going to do just a quick, simple demo. Let's see if it works. This is going to be the basics. Sorry. I mentioned one of the options that we use, the open policy agent, is replace the pod security policies, and we are looking to gatekeeper. It's one of the options for Kubernetes, but then everyone now is going to be shift left. Do you know what's the concept of shift left? Okay. How many of you know? Okay. Good, good, good. And the other ones who don't know, don't worry, it's coming. So the concept of shift left is it's trying to integrate not just security controls or features. It's early in the process of the development, so it's faster and it's quicker to get feedback when the developer is starting to create their code and before it's being deployed in production, because otherwise there are multiple steps that it's going to be more expensive in time and other things to roll back or update that. So I'm going to just do a simple example of, I have some files, and we have a deployment, and we have a policy written in Rigo. So this is the policy, okay? It's very simple. It's like, I want that when you are validating deployments, I don't want to run it as non-root. If you detect that that's a problem, then stop it. And the same if you don't have labels. But there are multiple other things that you can do with Rigo. And then we have a normal deployment, hello Kubernetes. So what I'm going to do is just like, I'm just going to copy that one to a new YAML. And then that one, let's do, so we have a cowboy in the business. And let's say, yeah, let's assume that they don't apply labels to anything because it's just test. It's never going to prod, so why? But eventually it goes to prod, okay? And then, so instead of merging the code, goes to review, the peers say, that looks good, YOLO, it's always good. And goes to staging, doesn't break, and then after some integrations, it breaks. So instead of waiting for all the pipeline to go through that, we can just do some local easy integrations. So I'm going to just add my favorite YAML, and I'm going to say, okay, yeah, Friday afternoon, let's do it. Oh, so luckily, before going to the pub, you see an error, and then you don't commit it. And then the company is safer because we don't have a random YAML that it's not properly governed. So I just did a simple trick and adding just a Git hook. So so this is very basic, but what this accomplishes is that it will get me the files that are going to be committed, and it will apply it with conftest, which is one of the tools that uses open policy agent Rigo to validate files and get an output from there. And it's just a basic example of how we can put controls early in the pipeline so that we are more secure at the end in the deployments and other things. You can do your own flavor of this type of exercise. Okay. So there are some few references that are really useful. I recommend in KubeCon, it's since in the last year and a half, it has been very trendy open policy agent. I recommend to look into it now that pod security policies are going out. And Rita Zhang and Gareth R. and other people from Stera, they are doing a lot of good demos. And yeah, we're sad that pod security policies might go, but there's code available already that it's the rigor equivalent of pod security policies. So we might have some light in the end. Okay, so everyone, that machine is hiring the best. So you're the best. You're welcome to join. You're not the best. You will become the best. Okay. Okay. Yeah. Any question? That's it. Okay. If you have questions.
Is that on? That is on. All right. And the next question is, will the screen work? And will the screen work, actually, what I need to do? Yeah. If I can, it turns out I have the smallest ears in the world. So it might or might not stay where it should stay. Right, let me just check. That's okay, up and running. Hi, my name's Liz Rice. I work for a company called Aqua Security. We help enterprises secure their cloud-native deployments. And we have some people in Aqua who do research. And the thing I'm going to talk about today is something that one of our team found, a chap called Daniel Segui. He's actually had to go off and do his military service, but just in case he's watching the live stream, he found this, and it's a pretty interesting and slightly scary demo. This is actually a talk that I did last week in San Diego at KubeCon, and I titled it, CapNet Raw and ARP spoofing. This is pretty much as, I thought this was actually quite a representative clip. How many of you here know what CapNet Raw is? Just to level set? Okay. And how about ARP spoofing? Okay, don't worry. If you didn't put your hand up, we will cover those things. So the demo that I'm going to show you, I'm just running it on a single node. It is a completely regular Kubernetes cluster that I installed using kubeadm, and I'm using a layer 2 network plugin that will become important. Everything about it is default, bar one thing. The only thing I've changed is that by default you get 2 pods for kubedns, and I've only got 1, and that's just to make my demo more reliable. But if you're using default Kubernetes and you're using a layer 2 plugin, this could happen to you. And because there's quite a lot of screens in the demo, I'm just going to talk through what is going to happen before I show it. So I'm going to have 3 application pods. One of them is the victim. That's the sort of normal application pod that perhaps it needs to be able to contact some kind of external or internal DNS location. And as Diego said, sometimes there are bad images out there. So somehow or other, a bad image has gotten itself deployed on your cluster, or one of your images has been compromised, perhaps because it has a vulnerability in it. In fact, 2 of them are bad here. One is the hacker pod, and one is the fake pod. So under normal circumstances, the victim pod, when it wants to talk to example.com, does a DNS lookup, domain name service lookup, to resolve example.com to an IP address. And it makes that request to a core DNS pod. Core DNS does the DNS lookup for it, gives back an IP address, and the pod is able to go and make the request to the right IP address. That's what's supposed to happen. In this exploit, basically, when the DNS lookup happens, the hacker pod is going to be faking that it is the DNS pod. So it's going to force its way in so that it gets the DNS lookup. And rather than returning the real IP address of example.com, it's going to return the IP address of somewhere else. In my example, I'm giving the IP address of a pod called fake, which is going to return something that is not what we expect from example.com. Okay, so let me get this up and running. Right, don't worry too much about what's happening in this top screen for now. And let me see if I've got any pods. Is it big enough? Can you read it okay? Yeah, great. So let's see what pods I've got running. Okay, all three of my pods are running that I described. And I'm just going to exec into them all. So this is going to be the victim, and I'll just run a shell in there. This is going to be my fake, run a shell there. And this is going to be my hacker. Run a shell in there. Okay. As the victim pod, I can make an IP request to, make a request to example.com. And we get back some traffic from, some content from the real example.com. Okay. So I'm going to set up my fake pod so that it's going to be able to respond in place of example. The first thing I need to do is get its IP address. I'm going to need that in a moment. And then I'm going to set up, let's say, hello CubeMass. I'm going to pipe that. So my fake pod is now listening on port 80, and when it gets a web request, it's going to respond with the content, hello CubeMass. Okay, and now I'm going to, in my hacker pod, there's some exploit code in here that we have published, and I'll give you the URL for that at the end. So I've got a hosts file that is a little bit like, any kind of DNS resolution file. And I'm going to say resolve DNS for example.com to 10.32.0.3, which is the IP address of the fake pod. So now my hacker pod knows what IP address it wants to redirect that DNS, those requests to, and I can run the exploit. And this just takes a little while to set itself up. Okay, now it's set up. It's taking over DNS requests in place of, it says kubedns, it's actually core DNS that's running. And now if I do the same curl to example.com, clear the screen. It's a little bit slower, but we'll see various DNS requests happening as it tries the various possibilities that example.com could mean inside a Kubernetes cluster. Don't know why it's, I ran this in WeWork earlier. Let's hope it does the right thing here. Probably will. Might try a few times. And here we go. There's the spoofed request, and there's our fake content coming back to that pod. Okay. Thank you. So we should probably talk a little bit about how that's happening. And it's happening because of ARP spoofing, as I mentioned. And ARP stands for Address Resolution Protocol. And in order to talk about that, I'm going to briefly talk about the 7-layer network model. In fact, we don't need to talk about all 7. We're only really interested in 3 of them. The application layer, which is where we make web requests and actually do fun things. The network layer that deals with IP traffic, and the data link layer at level 2, which is typically things like Ethernet. At layer 7, we deal in URLs. those get resolved using DNS, domain name service, lookups to IP addresses. And IP addresses are mapped to MAC addresses using this protocol called Address Resolution Protocol. So if you're using a layer 2 network, this is how you know where to send messages to. You need to look up the MAC address that corresponds to the target IP address. So the ARP protocol builds up a table that would look something like this, mapping IP addresses to these MAC addresses. In sort of normal terms, the MAC addresses were unique identifiers that were kind of hard-coded into every piece of layer 2 network hardware. Nowadays, particularly in Kubernetes, a lot of them are virtual. They're not real Ethernet cables, but they're fake Ethernet connections, and you get kind of made-up MAC addresses. So I want to talk a little bit about how pod networking works. We start with our host machine, where our pods are going to run. And if we're talking about layer 2, there is a bridge that holds that ARP table that sits in the network namespace for root. When we create containers, or containers that are inside pods, they get their own network namespace. And if I create a pod that's called pod A, in its network namespace, it's got an Ethernet connection that kind of looks to the container just like the root one does to the host. And there's a kind of virtual connection between the Ethernet. It's as if there were a cable plugged in between the virtual Ethernet connection and the bridge. Same for pod B. So from the bridge's point of view, it thinks it's connected to two Ethernet interfaces, one for each pod. So if pod A wants to send a packet to pod B, and it's got the IP address of pod B, well, the packet doesn't have anywhere to go other than this Ethernet connection, so it goes there and through the virtual Ethernet connection and to the bridge. And at the bridge looks in the ARP table and to say, do I know the MAC address for this IP address for B? And let's say it does, then the MAC address will correspond to the virtual Ethernet connection for pod B, and the packet gets sent there, and that's all good. If the IP address isn't on the same node, so let's call it address X that is running somewhere else, it leaves pod A in the same way, goes to the virtual Ethernet connection, goes to the bridge. Doing the ARP lookup, there is no entry on this node because there's no connection into this bridge for that particular IP address. So the packet gets sent to the sort of external, well, other things might happen, but at this point it becomes a layer 3 problem, and it will end up going out of the Ethernet 0 interfaced on the host. So ARP spoofing is where you pretend that you own an IP address that you don't actually own. So you're basically populating the ARP table with incorrect information. So you're saying, if you've got an IP address for whatever that address is, send it to me. And the bridge doesn't know any better. You've told the ARP table, this is to send packets to me, and it happily will. If you are able to send ARP packets, there is nothing to stop you from taking over any IP address on the node. We'll come to why it has to be on the node. Well, actually, it was because the ARP table represents only the IP addresses that look as though they're connected to that bridge. So you can only ARP spoof for addresses that are for IP addresses that are considered to be on that node. So in my demo, I had the victim pod. I have the hacker pod that is faking. It's able to send these ARP requests, and it's faking the address of the core DNS pod. So it's looked up what the IP address of the core DNS pod is. core DNS IP address has to be on the same node, but the hacker pod just keeps saying, no, 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 it's not over there, it's me, send me the DNS request. I am the IP address for DNS lookups. And the bridge doesn't know any better, so it populates the ARP table with that hacker's IP address. So the victim makes a DNS request. When it makes a DNS request, it's sending it to the IP address of the core DNS pod, which the bridge thinks is on the hacker pod. So it just happily sends that request to the hacker. And the hacker can then respond saying, yeah, that IP address you wanted to look up, it's over there on the fake pod. So the DNS request is the thing that's looking up the IP address by domain name. And you're sending that DNS request to an IP address. So if you are co-located with the DNS service, if you're on the same node as the DNS service, and if you're able to do ARP spoofing, you can take over DNS and populate that ARP table with anything you like. Well, no, return DNS responses with any addresses you like. You could even be redirecting to the incorrect external IP address. One way to stop this from being possible would be to stop the hacker pod from being able to send any ARP packets. If it can't do that ARP, the address resolution protocol, it can't mess with the ARP table on the bridge. And that's really why this thing called CapNet raw exists. So the cap bit stands for capabilities. And in Linux, there are, I don't know, a few dozen capabilities. They're really granular controls over what you can or can't do, or what a process can or can't do. And under normal circumstances, there's no real reason for applications to need to send what's called raw, to open raw sockets, to send raw packets. Because normally, applications are operating at least layer 3. If you want to send packets at layer 2, you need this CapNet raw permission, if you like. And if you want to do ARP, ARP is at layer 2, so you need this CapNet raw. So if you don't have CapNet raw, you couldn't do this. If our hacker pod doesn't have CapNet raw, it can't mess with the ARP table. And we can control that by setting or dropping capabilities within a pod security context. I've actually got a pod definition that does this. I think it's right here. No, I need to quit out there first. Yeah, so here is my pod definition for, this is exactly the same as the hacker pod, except I've added net raw. Now, this is why I have this tracing thing up here, which is tracing what's called cap capable. This is checking what capabilities are available. And all these previous CapNet raw checks are where the hacker pod was making ARP or sending ARP packets, and it had to check whether or not it had CapNet raw. If I create from that file, hacker pod, there we go, and I can exec into that pod, hacker drop cap with a shell. And if I try and run the exploit in here, it's going to fail because we'll see it try to make the CapNet raw check, and it doesn't have CapNet raw. We had to drop that capability, and the exploit fails. So there's that first attempt to do something that requires CapNet raw. And the exploit code doesn't cope well with that and fails. So if you can drop CapNet raw, perhaps using an admission controller like Diego showed you, that is one way to prevent this exploit. Pod security policy that requires you to drop capabilities would do that. There is a thing called Gatekeeper, which gives templates for Open Policy Agent. And they have this repo on GitHub called pod security policies. And at the moment, it implements everything that's currently in pod security policy. So you wouldn't have to write an admission controller. It's just all there for you for everything in a pod security policy, except right now it doesn't cover Linux capabilities. Although last week I was talking to one of the maintainers of Gatekeeper, and she was saying they are going to add this soon. So hopefully next time I run this demo, I could actually use Gatekeeper to prevent the exploit. There are also things that you can do at the kind of network layer to stop this exploit being possible. And one of them is to use layer 3 networking plugin. How many of you are using Kubernetes? Keep your hands up if you know what networking plugin you're using. And keep your hands up if you are using layer 2. Yeah, okay, a few of you. If you're using layer 3, you are safe. And the reason why you're safe is because the ARP table doesn't really come into it. If I were to run the same exploits, it gets these kind of MAC addresses that are nonsense, really, because MAC addresses just don't come into it at layer 3. Another thing that you can do is use secure connections for the DNS requests. And that's actually turns out to be a very simple config change. So I recommend making this configuration change to the config map for core DNS. Just really to sort of sum up, to do this DNS spoofing requires, but only requires, using layer 2 networking, a compromised pod that happens to be co-located with the DNS service, and the compromised pod having that capability to do raw packets. But that is the default. If you want to find out whether your cluster is affected, one way you could check it would be to try the exploit, which I'll give you the link for. Another thing would be to run a tool that we have called KubeHunter, which it's a bit like penetration testing for Kubernetes. And you can run it both external to your cluster, or you can run it inside your cluster, which simulates what an attacker would see if they compromised a pod. What could they do from there? If you run KubeHunter as a pod, it has checks for this, both ARP spoofing and DNS spoofing layer. And you can get all those things from GitHub. So Daniel's code for the exploit is Daniel Segi kube DNS spoof. KubeHunter, which I just mentioned on the Aqua Security GitHub, and also Tracy, which was the tool I showed you that was tracing out cat capable, and it can also trace out system calls from containers. So if you're into that kind of system call layer, it's actually a really neat little tool. And of course, justgiving.com/fundraising/Kubemas-2019. Please give generously. Thank you very much.
Thank you. Where is Andy? No questions. Hold on, which question?
So the reason that pods all have CapNet raw, it's been on my backlog for 4 years, and like I thought it would be an easy fix, and this is one of the things that's interesting about security. Is like, so the reason it's there is because people complain if you can't actually use ping between one pod and another, and ping has historically under Linux required CapNet raw, and like if you couldn't ping one container from another, people would say like, oh, the networking is not working, and really complain to the networking people, and Brian would have to deal with it, but Linux actually added this feature about, I think it was about 6 years ago, that there was a special thing called ping sockets that didn't require CapNet raw, required a different privilege. And it was like, oh, it's going to be easy. We're going to, like, all the Linux distros are going to introduce ping sockets, and we're going to be able to remove CapNet raw, enable ping sockets. Like, everyone's going to introduce them. We're going to be fine. And it's like, maybe it'll only be like Ubuntu 14.04 that won't have ping sockets. It's like years later, well, Alpine Linux has ping sockets and no one else does. If I've introduced remove CapNet Raw, it's like literally still going to break ping. And that's been literally the case for years, and it's really annoying. And like, it's one of these things that's just really difficult. And so it's like, I mean, we should just remove it as the default, and you have to actually add it. But it will just annoy all the networking people, and it's just one of these things that's just really hard backwards compatibility things. Should we just get rid of it and make it more secure?
Oh, should we not?
Should we not? Come on.
I think there's a few abstentions though.
Okay, well, so I think
I think we should let
the vote now says we should just remove it anyway. So okay, so we'll do that. So yeah. Anyway, Andrew.
Well, technically, it was not a question. Anyway, while Andy tries to put his Windows machine on, who is coming to the meetup for the first time? Oh, wow, welcome. Welcome. Did it work the first time? Oh. Oh, yes. Is anyone here who wants to give a talk to me or Milos? If you would like to give a talk and you don't know very well how to do it, talk to me. Talk to me. We can help you. We can help you to prepare the talk and help you to give the talk. Don't be shy. Or be shy and brave. Thank you.
Sorry.
Are you going to do a demo? Then you can use this.
Okay, I'm happy to. Whoop. Come on.
Window. You have 15 minutes. Keep just playing. Oh, we have the pub now. It's the Singer Tavern. If you don't know where it is, do not follow me. Follow.
Do not follow this man anyway. He is a danger to you all. Right. Hello, my name is Andy, and I'm going to do a whistle-stop tour through how to train financial services red teams for Kubernetes. We open source a load of things. At the end of this was first presented at Liz's Aqua KubeSec Summit last week, and it is not a 15-minute presentation, so I'll do my best to enunciate. Hello, I'm Andy. I do all these things. I like stuff, especially if I can break it. I am very proud to say I'm writing SANS 584, security training course for breaking cloud-native microservices, and I'm a trainer for lots of other things. I care about training, I care about people, and ultimately the only way that as an industry we can increase our baseline of security is if we do better at educating and being free and open with information, which is why open source security is so bizarre it took so long to actually take hold. I'm a founder of Control Plane, which is SecOps for Kubernetes, and we focus on regulated industries, financial services, and difficult stuff. And I want to talk about how we understand the cloud-native threat model and how we upskill and train the next generation of cloud-native security engineers and architects. So, Kubernetes has had insecure defaults for a long, long time and multiple CVEs of earth-shattering proportions. Common attack vectors can route the cluster end-to-end, and these are fixed by adding controls. Controls are just a way of preventing something from happening. It is a posh way of saying an automated check or a gate for something. Then, how do we know those controls are applied? Well, we need to test them to ensure their veracity. Are they doing what they say on the tin? And this means we have to understand what they're doing. This means we have to address the skills gap. Architects need sufficient knowledge to build the systems. They need to know the topologies. Engineers need to understand how these things are laid out, and security engineers need to apply the controls themselves. And red teams need to have sufficient knowledge to exploit our clusters. So I am here today to talk about attack trees, which are a visual representation of a system's security, and CubeSim, a security training tool for everybody. So Kubernetes won everything. We all know that. All these companies had the same struggle to secure their systems. There are two fundamental barriers to deploying Kubernetes from a security perspective. They are CVEs abound in non-trivial code, and Kubernetes is complex, as we would expect of any project of this size and velocity. And secondly, Kubernetes is insecure by default, which the original founders of Kubernetes are still not very pleased that everyone's going and keynoting about at KubeCon. But frankly, this is the situation we're in. Security releases, however, are fast. The project has a stated goal of fixing problems or serious CVEs within 7 days. For comparison, Project Zero, which is Google's break everything you can see hacking team, have a 90-day disclosure window, which is more industry standard, but there's a huge disparity there. 7 days is nuts and probably industry leading, especially for an open source project. And the security team are composed of a set of high caliber individuals from the top echelons of the world's best software development houses. So vulnerabilities happen. In that case, clusters must be deployed with a layered set of controls. That means the failure of one control does not affect the overall ultimate security of the cluster. This is otherwise known as defense in depth, because we don't know where the next 0 day will come from. And in terms of controls, I've mentioned that Kubernetes is insecure by default. That is to say that the security functionality is available, but it is not enabled. Why is that? Well, default doesn't really exist. There is no standard Kubernetes. We've centralized on kubeadm for most cluster bootstraps, but kubeadm is a developer-focused tool. It does not give us all the Belgian whistles that otherwise we need to keep our clusters secure. So this means for any new cluster administrator, this is the start of a bad day that is about to get worse. So what attacks are possible on insecure clusters? I hear you cry. This is not the focus of the talk, but there's a whole host of risks that an insecurely configured cluster is subject to. And we will see later how we can educate and upskill people and teams to appraise and remediate some of these risks. This is not exhaustive, but I attempt to be exhaustive later. Now, historically, the pace of feature delivery has outstripped the speed of security functionality. Is this the right decision for the project? Indubitably, because everyone's using Kubernetes. So while this is a bad story for regulated industries, let's say, it is certainly a good story for the pace of the project's development, the velocity of adoption, and the speed of contribution, the growth of the contributor base, etc. Everything in life is a compromise, and the developer-focused path to general adoption was probably the right one. And with that, the story has, of course, become better with time. Kubernetes has shipped a whole host of security features, but really the essence of what I do day to day is cutting through the noise, identifying which controls are relevant for which application, which organization, which pipeline. So security teams typically do not like what they do not know. And they generally don't know Kubernetes or cloud native. Cloud native expertise is a rarefied skill. This is what your security architects are probably used to looking at. Whereas this is what an attacker is used to looking at. Attackers see things differently. They go low level, they don't have architecture diagrams, they are by default sniffers and priors. So we have a skills problem. To derive the controls to defend our clusters, we must understand the entirety of the cluster. All of those organizations mentioned previously have had to understand the security implications of running Kubernetes and had to develop expertise for securing and configuring those things. We know this is a challenge today, and we're going to talk about some security modeling techniques. 7 minutes, okay. That make it easier for an organization to decide which controls to apply when implementing and securing Kubernetes. All right, threat modeling and attack trees are of great value. They are a way to reason about the cluster and about attack or kill chains that attackers will take, and you can present them back to your security teams and give them something to hang their controls off. We will look at these. So, yeah, I mean, it's just threat modeling is a good way of getting a shared understanding between a group of stakeholders. And there is a canonical tome on the matter by Adam Shostak. It's a good book. It is a hard read, but the core principles are really very simple. This is a process of equalization among stakeholders. No one is more or less equal. Development know where the bodies are buried. The test team know what compromises have been taken to test services deep in a microservices call graph. Security don't know anything, and they just want people to tell them. But nobody will ever volunteer this information to them unless it is done in a non-violent space. This is the essence of threat modeling. Spreading the net of potential opinion has huge advantages, and the unexpected regularly rears its head. So how do we start building a threat model? Annotating an existing architecture diagram is a good place to start. They are things that we already have. We hope they're vaguely representative of the current state of our system. If you have to, use Stride or Pasta or one of these other things, but really do not let process get in the way of getting your hands mucky. For each point on the graph or diagram here, immerse yourself in the data flows. Think like an attacker. What's going through here? Which code paths could potentially be exploited? What, in the event of compromise, would I try and pivot to? Are there data stores open? Can I use the privilege inherent in the container, or the service account in this case, to do something else? Do I have, for example, some sort of link to an IAM or a cloud provider account that I can use and exploit my service account? Credentials, encryption, privilege, further access, etc. So we describe these things, and then we write them up as prose. Here is an example of just drawing something to try and get our heads around what Kubernetes actually is and what it's doing. Trust boundaries are important. Within a trust boundary, we would expect there to be danger should compromise occur. As an aside, we can use standards like the CIS benchmarks to generate a set of controls, but how can we know if they're comprehensive for our use case? What technical debt have we accrued to ship the system on time, in budget, etc.? There's only one way to gain confidence, and that is to internalize the attacker's mindset and do the best we can. This is what red teams are doing for a day job. This is the art of the threat model. If I can get remote code execution in an application running on your Kubernetes cluster, I will enumerate everything I can find and pivot relentlessly. And that process can be mapped using an attack tree. As Bruce Schneier once said, we're looking to formally and methodically describe the security of our systems from an attacker's perspective. So here's an attack tree, typically described using a top-down approach. These are simplified for the point of explanation. We start with a negative outcome that we want to avoid. At the top, malicious code in workload. And subsequently ask, how could that be achieved? This is useful when working with security teams who have identified all of the negative outcomes they do not want to occur, because there are numerous lists of terrible things on the internet that make security teams unhappy. To explain the key, the shape dictates whether a node must have the sum of its children, or either or, I mean, it's an and or an or, in order to realize the node that it joins. And this is a simplified subsection of an attack tree. We'll look at this slightly larger. In this case, it's just a poison container image, and it is predicated on the fact that we have poisoned the registry initially, and then we use either the churn of nodes coming up or just the deployment to get that deployed. And there we have our malicious code running inside the cluster via some route of exploitation that we may not expect. For example, a developer's end user device has been compromised, their credentials are exfiltrated, and somebody is able to get something into the registry. Right. In reality, attackers are able to gain some small level of access and ask themselves, what do I do now? This can be reflected by using what we call a bottom-up approach, shown here with another simplified tree. In this case, we start with remote code execution in a container, and the diagram is a little hard to read, so let's look at the lower half. With that RCE, we can potentially do many things, 12 minutes. But in this excerpt of a tree, we focus upon how the container's service account token, if sufficiently privileged, can be used to start other pods, exec to a running container, or extract secrets. Subsequently, we can see how this could lead to pulling or pushing images from an image repository, unauthorized access of data, crypto locking, ransomware, all the bad things on the list. As you can see, attack trees are not particularly complex, but when composed into a greater diagram, are a hugely useful abstraction to reason about the security of our systems. So, once attack trees are created, one can use them to map controls onto the cluster. We tend to create attack trees assuming that there are no controls in place initially, and once we map the controls onto the tree, we expect to see the number of nodes and branches shrink. So by cutting the branches, we are essentially preventing that branch of the tree from being exploited and integrating our control. This is also an important point where we automate our security regression suite. Security is just testing. Testing is just identifying code paths that we don't expect to run and running them. And we can do our happy path testing and pray that our systems actually work, or we can do proper testing and be quite brutal with them before they hit production. And then when somebody gets remote code execution and actually performs the testing that we should have done as developers earlier in the day, we're in a better place. So what else can we do here? We can enable a security operations center, which is a centralized point for logging and with general monitoring and alerting across an organization to preemptively calibrate their alerts based on what is generated from a cluster when it is attacked. We should know this should not work. We shouldn't be able to receive this particular alert or warning because we've applied a control. We can use software engineering rigor to stand up test harnesses, to use lots of these useful mini Kubernetes distributions, especially like Kind, and build acceptance test harnesses where we can automatically attack clusters, generate the events, and then ensure that our SOC and SIEM teams have the relevant notifications and alerts raised at those points. So, over the course of 2 months, Control Plane worked with a major financial organization to threat model Kubernetes end-to-end, focusing on workload abuse and asking the threat modeling questions. What can go wrong to the API server, to etcd, the kubelets, the CNI, the CSI, workloads, various permissive configurations that can be granted, cloud provider integrations, metadata APIs, and more. And there is further development that continues to this day between Control Plane and the financial services team. And we are ecstatic that we were able to open source and share this work. Here is a more comprehensive example. This is a fuller attack tree. And these are all available in the CNCF Financial Services GitHub, which I will link to at the end. So, threat models and attack trees are difficult to generate if subject matter expertise is lacking. As I've hackneyed already, everybody gets better at their defensive jobs if they understand the nature of the assault. And Control Plane have collaborated with a customer to open source a cluster provisioning and attacking and defending tool for educating blue and red teams, especially red and blue teams, which are the internal angels and demons within an organization that ensure nothing unexpected, as in nothing that has not yet been tested, hits the organization from outside. They maliciously attack themselves, and blue teams then remediate and do the opposite. So, in order to increase the security awareness of individuals looking to understand the security implications of cloud-native space, we have built a cloud-native security simulator called CubeSim.io. There is a hosted version, which is optimized for teams and organizations that are unable to stand up vulnerable infrastructure within their estate. And there is a fully end-to-end open source version for everybody else. This demonstrates attack, defense, and remediation principles in a safe space where teams and individuals can experiment with impunity. It provisions infrastructure, it loads challenges, scenarios, gives us hints, scoring. It is a raw command line experience, as if we had just broken into the cluster, and it is all open source. There are a huge range of scenarios already, and incidentally, these take inspiration from military terminology. Here is an example. In order to change the cluster's RBAC, we reviewed audit logs and saw something was awry. We shouldn't be able to do this. This particular container is the origin of these events. So we start a pod, we verify the attack is possible, we examine the permissions bound to the service account, we dig a little bit deeper and remediate the issue, and then add a defense in depth approach, applying best practice for a financial services organization in an open source training tool. For those of you who would like to try it, these demos are no longer up, and I should have removed this slide, but you can just pull the thing. So yeah, clone the thing, use your AWS keys, and see if you trust code you pull from GitHub. So what are our learning outcomes? We're looking to understand all the ways that Kubernetes can possibly be vulnerable and teach users how to fix everything. Application workloads, container images, applications, operating systems, dependencies, file system configuration, users, baked-in secrets, malicious images, workload configurations, pod specs, privileged environment variables, service accounts, workloads, identity, data stores, traffic sniffing, Nmap, ARP spoofing, cluster configurations, developers, authentication, RBAC, network policy and networking, operations, admission control, etcd, encryption, control plane TLS, local and remote registries, dashboard and APIs, federated identity, control plane configurations, user access topology, transport TLS, infrastructure cloud, operating systems, and more. But wait, and here's that list for posterity. We're still in development. We have a list of 25 scenarios, and we would welcome contributions or requests for configurations specific to your organization. 18 minutes and 43 seconds. I thank you.
Thank you, Andy. It was good. A little bit fast.
Oh, I'm awful sorry.
So can you put the thing the giving page?
Oh, I didn't put it in these slides. No, I can't. Tell me what it is.
All right.
Is it there?
I cannot say. Yeah, it's that one.
This one?
Yeah.
That was lucky, wasn't it?
And now the slash cube. Cube. Dash. Dash. 2009.
2019.
Yeah, I think so.
Yeah?
Could imagine one word.
Oh, the bag on that.
Yeah, like this. Yeah, remove that one. So we will release the slides once this thing reaches. Thank you for coming.